Today we're starting 2.3, converting between fractions and decimals. Just as a reminder, chapter 2 is not a calculator chapter, okay? It will come, but for now we're still kind of working through that math. The first thing I want you to do is pull out your red pen. The things that you see here, I want you to go ahead and write them in red pen on your paper. Remember, we're working on section 2.3. So the first vocab word today says terminating decimal. How many of you guys have ever heard of someone saying their job was terminated? What does it mean if someone's job is terminated? Okay, maybe they got fired, all right?
Maybe their thing went out of business.
Okay, maybe the store went out of business, so they couldn't work there anymore.
Laid off.
Maybe they were laid off, okay? So terminated means their job is done. It's over, right? Well, a terminating decimal is a decimal that ends. A terminating job, it's a job that ended. A terminating decimal is one that ends. So you can see, for example, what did you guys write down as your example in red pen? 4.75. That has an ending. Okay, here's another example. You don't have to write this down, but 1.2. It ended. Who can give me another example of a terminating decimal? A decimal that ends. 1.3. Okay, very good. So those are terminating decimals because they end. There's another one. This is called a repeating decimal. This is a decimal with one or more digits that repeats. Everyone say repeating decimal. Repeating decimal. Repeating decimal. Repeating decimal. Would you like me to continue? I am quite sure at this point you understand a repeating decimal is a decimal that repeats. So here you can see we've got 1 point what, guys? 36, 36, 36. Guess what would come after that? 36. It would just continue on and on and on. What two numbers are repeating? The 36. So guess what another way that you could write this? I want you to put this off to the side. You could write that as 1.36 with a bar notation on top. Now, if you notice, I only put the bar notation on top of the 36 because it's only the 36 that's repeating, not 1.36, okay? So now what I want us to do is to understand and see if we can figure out the difference between terminating and repeating. Example A, 1.4. What do you think, guys? Terminating or repeating? It is terminating because it ended. Okay, that is terminating because it ended. Once again, we're writing this with our pencils. You do not need your red pens anymore for today's lesson. The next one says 5.6, and it's got a bar notation or a line on top of the 6. What does that little line or the bar notation mean? It's repeating, so this is obviously going to be a repeating decimal. So if that went on, it would be 5.66666, and only the 6 is repeating. Okay, let's go to the next one. 6.53. Is that terminating or repeating? How can you tell it's repeating? Okay, it has a line above the 5 and the 3. So explain to me what it would look like if it kept going. What would it say? 6. Excellent. It is only the 5-3 that is repeating. Very good. For this next part, it says write the fraction or mixed number as a decimal. Now, this is things that you have done in the elementary, but I think a lot of times we forget about the things that we've learned before. So let's just think about this. -2 and 1/4. I need to change that to a decimal. Does anybody know what that would be as a decimal?
2.1.
No, it's not 2.1. Okay. Let's see if we can go ahead and turn this into an improper fraction. What would this be as an improper fraction? Okay, 9/4, all right, because what you did here is you multiplied this, 2 times 4 is 8, and then you add the 1. So that makes -9/4. Okay, once again, you're keeping the negative, because if that was -2 1/4, this is -9/4. Now that I have this fraction, does anybody know how I would turn this into a decimal? I've got to see how many times can that 4 go into the 9, okay? In order to do that, I just want you to come up here. You're going to want to write kind of small. 9 divided by what? 4. Now, after the 9, there is always an imaginary decimal. So I'm going to go ahead and put a point. And then what I like to do is I put 3 zeros. You might need those 3 zeros, you might not need them, but we are going to go ahead and put 3 zeros to help us as we work this division problem. Does anybody know what I need to do with this decimal point? Bring it up. Think of it like an elevator. Whoop, and it goes up to the top floor every time. Okay? Now let's figure this out. How many times does 4 go into 9? 2 times. Put the 2 on top. 2 times 4. I need more than just Rodney to help me. 9 minus 8? 1. Compare it. Is the 1 smaller than that 4? Yes. Drop down the 0. How many times can 4 go into 10? 2 times. Put the 2 on top. 2 times 4? 8. 10 minus 8? 2. Bring down the... How many times can 4 go into 20? 5 times. 5 times 4? 20. What's 20 minus 20? 0. Now listen, when we get to this 0, it's like a yay. Why? Because we're finished. Okay? So, I still had a 0 up here, but that was just an extra 0. I don't have to keep going because really it would just be 2.25000000. And you can let those zeros at the end float away and be gone. Okay? So, my answer is not just 2.25. Did you see what it is in the beginning original problem? It's negative. So what I want you to do, I don't want you just to box in this answer up here because it looks sloppy, okay? So instead, just come off to the side somewhere. It's going to be negative 2.25. Now listen, back in your elementary days long ago, there was a time when you memorized what fractions equal what decimal. Does anybody know what decimal 1/4 would be? It is 0.25. So if you want to write this somewhere, 1/4 equals 0.25. This is one of those facts that you could memorize, and from now until the rest of your days, you would not have had to work this whole thing out, because you could have just known it was going to be -2, and then this was 0.25. If you notice our answer right here, -2.25. If you don't have the fact memorized, though, you can always work it out by long division. Let's go on to problem B. 5/11. 5/11 is not one of those facts that you maybe have memorized. So this is something we're going to have to work out, okay? But the good news is it's not a mixed number, so I'm just going to do it just like this. 5/11. What do I divide? Incorrect. I have a lot of you who just said 11 divided by 5. I want you to think about when you're born. How many of you would say you are the oldest sibling? Okay, you're the first one. Okay, we're not going to skip over you. So the first number we see here is this top number. If you're the oldest sibling, you're the one on top, okay? So we have to do that number first. It doesn't matter who's bigger, okay? You might have a brother who grows up and he's taller than you, but you're still first, okay? So 5/11, the 5 comes first, and then you cover it up and divide by 11. Now, once again, you're going to want to write kind of small because we never know how long a problem might take us, okay? So do it off to the side. What can I put after the 5? A decimal point. And how many zeros do we like to do? Let's do 3. Remember, we might use them all or we might not. What should I do with my decimal point before I get started? Bring it up to the top. Remember it like an elevator. Whoop. Can an 11 go into a 5? No. Okay, so technically it goes in 0 times. You can put a 0 there if it helps you. Now we're looking at this. Can an 11 go into a 50? Yes. How many times? 4 times. 4 times 11? 44. 50 minus 44. 6. Okay, if you need to, you can borrow. 10 minus 4 is 6. Okay, now we're comparing. Is the 6 smaller than that 11? Yes, it is. So now we're going to bring down the 0. Can an 11 go into a 60? How many times? 5 times. Put that 5 at the top. 5 times 11? 55. Subtract 60 minus 55. 5. Okay, 10 minus 5 is 5. Is the 5 smaller than the 11? Yes, bring down the 0. Can an 11 go into a 50? Yes, how many times? 4 times. 4 times 11? 44. 50 minus 44? 6. Is the 6 smaller than the 11? Yes, what do I do next? bring down, okay? Now listen, I don't have enough zeros here, but I'm going to just keep bringing them down. You can add as many zeros as you want. 11, can it go into 60?
Yes.
How many times? 5. Does anybody see a pattern?
Yes.
What is repeating?
4, 4, 5.
Okay, 0.45. So how would I write that? Instead of saying, and I could keep going, instead of saying 0.4545454545, Emma, what would I say?
Put a line above 4 or 5.
You are correct. Put the line above the 4 and the 5. In order for this to be simplified, this is the way that I want you to write the answer. Okay, now once again, I do not want you just boxing this in over here where you've shown all that work. I want you to rewrite the answer and make it look nice and neat over here. Okay? I know as you were doing that, it might have squished into problems C and D. I probably should have given you a little more room to work there. Okay, so let's look at this one. It's a mixed number. I don't want it to be a mixed number. I would rather it be an improper fraction. What would that be as an improper fraction?
32 over 27.
32 over 27. Okay, so just put that directly underneath it. Remember, because when you're doing this, all you're doing is you multiply those together and then you add the 5 and you keep your same denominator. Okay, how do I figure out how to turn 32 over 27 into a decimal, class? Divide. What am I dividing? Okay, very good. Thank you for telling me. I start with the top number, 32, divided by 27. Now, once again, you're probably going to need to write kind of small. What can I put after my 32? A decimal point. Now, listen, someone said zeros. I cannot just stick zeros because what does that mean? That now says 32,000. Okay, so please make sure you've got your decimal point there. What should I do with that decimal point now? Bring it up. All right, can a 27 go into a 32? Yes, how many times? 1 time. Put the 1 over the 32 because we're not just sticking it into a 3. 1 times 27? 27. Let's go ahead and subtract this. What do you get? 5. Is the 5, because we got to compare, is it smaller than the 27? Yes. Bring down? Bring down the 0. Now here's what I do a lot of times, and I hope this helps you. That 27 is very similar to another number that we know how to count by very easily, a 25, okay? So we're going to kind of think of it like a 25 to get our best guess to see how many times that 27 can squeeze into a 50. If it was a 25 can go into it how many times? 2 times. But this is a 27, so how many times can 27 go into 50? Only 1 time. Put that 1 up at the top. 1 times 27? 27. Now we've got to subtract. What do you get when you subtract it? 23. Compare it. Is the 23 smaller than the 27? Yes, it is. Bring down. What do I bring down? 0. All right, so this is kind of a big number. We're trying to figure out how many times 27 can go into 230. Does anybody have a guess? Remember, when you're guessing, round that 27 to something similar, to either a 25 or a 30 to get your best guess. What'd you say? 8. She says an 8. Let's try out an 8 and see how we do. All right, now, if you can't do the mental math, you can always go off to the side and do 27 times 8 on the side. If not, you can try to do it in your head. So first we're going to take the 8 times the 7. What is 8 times 7? 56. Okay, so you've got the 6 on the bottom. Think about it now. We've got a 5 on the top. Now you've got to multiply the 8 times the 2. What's that?
21.
16 plus the 5
21.
is 21. Okay, so you get 216 when you do that. Now we've got to subtract it. What do you get when you subtract? Just 14, okay? Compare it. Is the 14 smaller than the 27? Yes, it is. So now what do I do? Bring down a 0. Now we've got to do another guess. How many times do we think 27 can go into 140? 5 times? All right, let's check it out. What's 5 times 7? 35. 5 times 2? Plus the 3? 13. 140 minus 135? Is it 5? Okay, I don't have any more zeros, but I can continue to write as many zeros up there as I want. Bring down that 0. How many times does 27 go into 50? One time. Okay, I'm going to spare us continuing to go on, but at this point, you can start to see our repetition, okay? Up here, this was a 50, this is a 50. So from that point on, we are going to be repeating. It will be 1.185185185 Okay, now once again, we could keep going forever, but instead I would like us to end there. So who can help me how to write 1.185185185 What would it be?
1.185 and I put the line over 1 and 0.185.
You are correct. We are only putting the line over the numbers that come after the decimal point because those are the numbers that are repeating. And remember, once again, put that number off to the side somewhere, box it in, and instead, I do not want you to box in the answer that looks like this because you're not showing me that it does continue to repeat. This next one I'm hoping is not going to be quite as hard. I want you guys to try to do this one on your own. And in just a minute, we'll check to see what you got. All right, guys, how do I find negative 6 over 5? 6 divided by 5, okay? Remember, I can put point and add as many zeros as I want. Put that decimal point on top. 1 times 5 is 5. Bring that down. 2 times 5 is 10. Ends at a 0. Yay! Now here's the deal. A lot of people just boxed it in over here. Remember, I don't want you to box it in at the top. I want you to rewrite it. But then on top of that, even those who boxed in 1.2, what's wrong with that? It has to be a negative. That was the greatest mistake that I just saw as I was walking around the class. Remember, if this says negative 6/5, this should say negative 1.2, okay? This next part you're not going to find in your notes, but I just want to make sure you know and understand this before we move on to the next section, okay? So this 2 is a whole number. A lot of times when we read this, we would say 2.456. All right, how many of you would say that's how you would read that normally? Okay, the 4, what place is the 4 in? 4/10. What place is the 5 in? Okay, read this to me. What does it say? 5/100. What is this? 6/1000. Okay, if I was to read this the proper way, it would be 2 and 456,000ths. Okay, because that 6 back here is in this thousandths place. So we're going to use this. You've got to make sure you understand and remember this from elementary school about how to figure out what the places are called. So let's go to this over here. Number 2. It asks us, now we're kind of doing the opposite. Write the decimal as a fraction or mixed number in simplest form. So that means we've got to reduce. Let's look at this first one. Notice this is a negative number, which means it's going to be a negative. Okay, so I'm going to bring my negative over. Let's talk about this 26 right here, 0.26. What place is the last number in? The hundredth. So guess what that's called? 26 hundredths. If I were to look at this, that says negative 26 hundredths. Now here's what it asks me in my instructions. To put it in simplest form, that means we have to reduce. Do you think there's any number that can go into a 26 that can also go into a 100?
Yes.
The number 2, here's an easy trick. If both the numbers end in an even number, it can always be divisible by 2. If we divide something by 2, we're just cutting it in half. So what's 26 divided by 2? 13. What is 100 divided by 2? 50. Is this a positive or a negative? It is a negative. At this point, are these both even numbers? No, 13 is odd. Okay, so we know for sure it cannot be divided by 2. And honestly, there's nothing else that can go into those evenly. So my answer is negative 13/50ths. All right, so this section is hopefully not going to take us as long as that last section we just did. Let's go on to problem B. Negative 10.25. Let's just focus on the decimal here. What place is the 0.25 in? You look at the last number. What number or what place value is the 5? Hundredths, okay? Because you're only counting the numbers that come after the decimal point. So instead of saying negative 10.25, we would say negative 10 and 25 what? What place is that 25 in? Hundredths. Notice you keep the whole number. The whole number is whatever comes to the left of the decimal point. I'm keeping that -10, but then you can also see 0.25 is the same thing as 25 hundredths. Can 25 hundredths be reduced at all?
Yes.
Yes. What number can go into 25 that can also go into 100? A 5. There is something actually bigger than a 5. What is it? A 25. So I am going to divide by 25 on the top and 25 on the bottom. Now remember, this is my whole number, so I've got to keep the whole number. Okay, so this equals -10. If I were to divide 25 by 25, what do I get? 1. Okay, and then 100 divided by 25? 4. So what's my answer? Can 1/4 be reduced at all? No, it cannot. That's as low as it can go. Okay, let's go to the next one. The whole number here you can see is 0, but I have some numbers over here to the right of the decimal point. What place does that 0.125 go out to? The thousandths. So guess what this is? 125 thousandths. I want everybody to say that for me. Ready, begin. 125 thousandths. Do you think there's anything that can go into 125 that can also go into 1,000? Okay, listen, anytime right here you see this, a 5 and a 0, for sure a 5 can go into that, all right? But then I heard a 25. Let me actually give you a clue. There's something even bigger than that. 125. Let's just show some work. Divided by 125. It is a big number, divided by 125. Okay, so if you think about it, 125 over 125 just means the number 1. So I'm just dividing by 1. I'm dividing by itself. So I'm getting an equivalent fraction. What is 125 divided by 125? 1. Now, we don't really know our 125 times tables, but can anyone take a guess of how many times you think 125 can squeeze into 1,000? How many? Guys, let's take an educated guess. 125 is near the number 100. How many times can 100 go into 1,000? 10 times. So it's going to be around the number 10. But we know it's going to be a little smaller than 10. 8 is the correct answer. 9 was a good guess. For those of you that are like, huh? You can always come off to the side and check it. 125 times 8. As you do that, you would figure out, oh yeah, it does equal 1,000. Okay, does that make sense? All right, let's move on to the next one. Problem D, I want you to try it on your own. Turn it into a mixed number. All right, guys, what do you think it should be? Okay, listen, what place is that 0.1 in? That's the tenths place. So we know we have a whole number of 3 and 1 what? Tenth. How many of you got that? Okay, if you didn't, that's okay. Go ahead and put it in. Here's what you got to remember. The first number is the tenths place when it's to the right of the decimal. The second number is the hundredths. The third number is the thousandths, okay? Let's go ahead and move on to the next page for me, please. For today, for the sake of time, I want you just to put a little smiley face there. We are not going to get to that problem. If you do it at home and bring it to me tomorrow, I will give you a piece of candy if you get it correct, okay? But you do not have to do it unless you want to. All right, so for this next one, we have a think, pair, share section. That means these are over the things that I just taught to you. What I would like you to do is try to do just problem number 1 on your own and stand once you have completed it. All right, 3 over 16. So here's what I want you to think, because a lot of people are still switching these up. Put 3 over, okay, so draw a little thing over, and then the 16 comes out on the outside. Decimal point, 1, 2, 3. Let's go ahead and put that decimal point up. All right, can a 16 go into a 3? No. How many times does it go into a 30? 1. 1 times 16 is 16. Subtract it. What do you get? 14. Bring down your 0. How many times does 16 go into 140? 8 times. What's 8 times 16? 128. Subtract it. What do you get? 12. How many times does 16 go into 120? 7 times. What's 7 times 16? 112. Subtract it, bring down the 8. Now, I didn't have enough zeros because I'm not sensing a pattern of repeating, so I have to keep going. Drop down another 0. How many times can 16 go into 80? 5 times. 5 times 16? 80. Officially, woohoo! We are happy because we reached a 0, okay? Can I just box in my answer right there? No, I need you to go ahead and put it off to the side and then box it in. Is this terminating or repeating? It is terminating because it ended and it doesn't have something that repeats over and over and over again. Okay, I want you guys to try number 2. All right, does anybody have an answer for me? Okay, I hear a negative 2.2. Listen, there's a couple ways we could have figured this out. If you have memorized 1/5, this is another one of those things that would be very smart to memorize. 1/5 is always going to equal 0.2. Okay, if you don't have that memorized, then I did teach you a little way. You could have just brought down the negative 2, and off to the side, you could do 1 divided by 5. When you do that, you can see it's 0.2. Then I would bring the 0.2 down over here and box that in, okay? Or you guys can go and have a seat. There's another way I also taught you to do it. How was that? Correct. We're going to turn that negative 2 1/5 into an improper fraction. If I did that, then I would have negative 11 over 5. When I do that, then you get 2 times 5 is 10, and it goes into it. So the answer there would be 2.2, but then remember, it was a negative up here, so you've got to keep it negative 2.2. Okay, but as you can see, that was done the same way. I do not care which way you work that out. Either way is fine. All right? Next up, the other kind. Once again, this is the kind of problems you're going to find on your homework tonight. If you get stuck, go back to these notes, rewatch or re-listen to this video on YouTube, and try to see if you can figure it out. Let's talk about this first. My whole number is 0, but my partial number, what place is that 6 in? What is it, class? That's the tenths place. So guess what this would be? 6/10. And is this a positive or a negative? Negative. It is a negative. Can that be reduced? Yes. What would it be reduced to? What is it? 3/5. Because you can divide it by 2. 6 divided by 2 equals 3. 10 divided by 2 equals 5. Okay, so the way that we did that is you are just dividing the same number on top and bottom. I'm dividing this by 2. And I have to do the same, divide this by 2. So that's how you get the 3, and that's how you get the 5. All right, guys, 0.408. What place does this 408 go out to? The thousandths, okay? So what would this be called? 408 thousandths. Do you think that can be reduced? Yes, there's a simple way to tell. They are both what at the end? They're both even numbers. So what number do we know for sure can go into it? A 2. Okay, that's a real simple one because they're both even numbers. When you're dividing by 2, you're just cutting things in half. Guys, what's half of 408? 204. What's half of 1,000? 500. Do you think that can be reduced at all? Yes, how can you tell? They're both even numbers, so let's divide it by 2 again. What's half of 204? 102. What's half of 500? 250. Do you guys think that this can be reduced at all? How can you tell? A simple way, these are both even numbers. Let's cut it in half again. What's half of 102? 51. What's half of 250? 125. Here you can see they're not even numbers, okay? And then you try to figure out, can a 3 go into it, a 4, a 5? As you think through it, you will see, nope. So the correct answer is 51 and 125ths. All right, yes, that was a lot of fractions. So listen, tonight's homework is to do 2.3. Did you guys see this number right here? What do you think that 8 means?
8 questions.
There's only 8 problems. So tonight when you're going back through your paper, you only need to complete 8 questions. Make sure you also submit it onto Big Ideas Math.